In this video, I'm going to introduce another scheduling scheme. So what this is called priority scheduling. This is a little bit different. Basically what happens, right, is if for every process in our system, we're going to have some extra piece of information associated with it that represents a priority. Now these priorities, you may wonder, how are they defined, right? How do we pick them? Well, there's some other mechanism for that, right? There's some mechanism that maybe we can label, oh, these things are high priority, these things are low priority. A lot of times what happens, right, is that there's maybe some, something ability operations that's like, well, if the user responds something that's, medium priority, if I need to do something, I can either say it's low or high, right, depending on what I need to do, right, some sort of background task. So usually there's some sort of a labeling system. Point again, right, is all my processes now will have some priority associated with them. Now, in our example here, we basically, added some notation here. So we have our tuples, right, that represent a process, right? So this is the one process. Before we basically had like P0 and then, just one number that was basically the burst size, right? So we had, P0 of 10 or 5 or whatever. Now we have, in addition to that, is our priority. So we also have a number that represents, what priority is this process with respect to the other ones. Here the priority will be the last entry in the tuple. So here I have basically priority 3 for P0. And then its burst size is 50. So it's a pretty long burst with, kind of a reasonable priority. Now for this, basically what we're going to assume is that lower priorities are better. So basically process 1 that has priority 1, so that should go first. Followed by process 0 as priority 3, followed by process 2 as priority 4, and then process 3 which has priority 5, right? So larger priority is kind of worse, right? Lower priority is better. So I have kind of my annotation there. I've basically added the information here. I've added those priorities to the end of each of these processes. That's going to control how I draw my little picture. So I have my picture there to represent, these are the orders that processes will run in. So obviously it's process 1 first because it has the lowest priority, as priority 1. And then process 0, right, which has priority 3, and then so on and so forth, right? Process 2, process 3. I'm just trying to order them by their priorities, right? So it's like I'm sorting the list of processes, and then I'm putting them right in the order based on increasing priorities, right? Well, as the priority number gets larger, right? It's implied basically that the priority number that's smallest is the most important one. And so I've ordered these, right? I have P1, P0, P2, P3. If I want, I can maybe even write the priorities over the top, right? So this is priority 1, priority 3, priority 4, priority 5, right? So they're all lined up like that. And then I have my annotations in the middle, right, basically to show the break. So P1 starts at time 0, runs until time 10. P0 starts at time 10, then runs until time 60, and so on and so forth, right? So we have basically our little marks there, right? So 0, 10, 60, 80, 90, right? I have those kind of just calculated from me putting these things back to back, right? And then seeing, how much time has elapsed. So that's the way my system would interpret processes. Then the question is, how well does it fare? So what I want to do is I want to look back at the metrics we've introduced, right? So we're going to look at waiting time and completion time. So over here, my completion time, that's pretty straightforward, right? That's me basically adding up, the end of each of the processes, right? So I'll add up, the 10, the 10 from the process 1, the 60 from the process 0, 80 from process 2, 90 from process 3. So I have those 4 things, right? I bring them together, average them out, right? And that's basically going to give me my completion time. So my completion time in this case is going to be 60 units, which is not bad. One sort of comment here really quick, is this number, right, we can't really compare it to the other schedulers. So we've seen things like shortest jobs first or first come first serve. It's not really fair for us to say that this number should be compared with the numbers those produce, right? Those actually had some really low times. I think it was 16.3 or something like that was how long, shortest jobs first took. It's not really correct or appropriate to compare our priority scheduler with that, because this priority scheduler has to worry about priorities, right? So it's actually satisfying an additional condition over just like, oh, I need to get all these things done as fast as I can. This priority scheduler is meant to instead, optimize for, oh, I need to have this thing done first, right? So in this example, right, for this program, I run in P1 first, right? P1 did not run first when we looked at the other example. When we looked at the example of short jobs first, it was something else. And so it's not really fair to compare them because they are solving different problems. This is solving the priority problem. Okay, so having said that, let's look at the second thing we have here. We also have waiting time. Waiting time, right, we kind of can measure it in a similar way. We're basically asking the question, how long does each process need to wait around for, right, versus completion time is how long does it take overall to complete. So here basically it's like, P1 takes 0 time, P0 takes 10 units of time, P2 takes 60 units of time, and P3 takes 80 units of time. So we have those 3 there, average them out, we get 37.5. So this stuff is pretty straightforward. We're just ordering right by the priority. So we have those 2 calculations, right? And again, they're not really comparable to the other algorithms. Now, as a final note, there is kind of a general issue that happens with this scheme. Now, if we have priority scheduling and we're basically treating it as a live algorithm, right here I've treated it as an offline algorithm. I've basically said, oh, I have all these things in advance. I'm going to sort them by priority, run them in order. Well, what happens, right, is if I try to make this algorithm a little more general, or maybe I want to run it in sort of like a live situation, what happens is you have the potential that you keep on creating new processes that are all of a low priority, and if you do that, those will be scheduled to run first, right? Because we're doing the ones that have that priority, right? That that low number, right? We want to run those first, right? We want to run those first, and we keep on creating processes that have priority 1 or priority 2 or priority 3. What happens is those things always get to go, and the things that have higher priority, right? Or I should say, lower priority mean a higher priority value. Those things, right, they may never get to run, right? I may never get to run, P3 with its priority of 5 if I'm constantly creating new jobs with the priorities of 1, 2, or 3, right? Because those will end up running first. And so that's kind of a potential issue here, right? We need to basically have a fixed set of jobs, right, that we schedule ahead of time, right, and then run those all at once, right, or run those all one after another. We can't just be adding new processes continuously, because then we get into that situation, right, where it's like, well, hey, I keep on, pay attention to new stuff. I never get to the things that are, older because I don't, because those have a priority that I don't want to pay attention to. So there's a potential issue here, and so generally you want to use this as an offline algorithm only.